There's some scientific research that truly exists in the forefront of exploration, endeavors which are difficult to say the least. But more often than not, it is those tasks which may seem impossible that are the most worthwhile undertakings.
80 meters.
80.
50 meters.
50.
Astronaut space detected. Altitude 40 meters.
40.
30 meters.
Oh, that's
27 meters.
We're slowing down. That's perfect.
20 meters. 50 meters. Standing back for touchdown.
The tenor of the country in the 60s was, as you know, uncertain. The youth had lost a lot of its enthusiasm for America because of the Vietnamese War. But the one program that seemed to unite all was the space program.
After igniting the country's imagination for space exploration, NASA turned to our closest planetary neighbor, Mars.
At the end of the Viking era, it was thought there was no life on Mars. It was a dry, kind of extinct planet, if you like. That volcanoes had not been active, that whatever water was there had only been active 3 billion years ago, and that Mars was a pretty unfriendly place for life. And then in the 80s, pretty much Mars activity stopped.
But a discovery made in 2001 by the Mars Odyssey orbiter showed evidence that water could exist on Mars, frozen, and just under the surface of the northern polar region.
Mars seems to be a more active, friendlier, perhaps a place where small oases of some kind of life could even still exist today if it ever started.
And so, after over 5 years of planning, designing, testing, constructing, retesting, and reconstructing,
0 and liftoff of the Delta II rocket with Phoenix. Distant science outpost seizing clues of the evolution.
Astronaut space detected. Altitude 40 meters.
40.
30 meters.
Oh, that's
27 meters.
We're slowing down. That's perfect.
20 meters. 50 meters. Standing back for touchdown. Touchdown signal detected.
This has got to be a huge step forward for the University of Arizona, and that tour de force of HiRISE taking a picture of it on the way down, that is excellence, and I think my word today is excellence. We're ready to do our science. We got the science of our dreams laid out in front of us. We got a spacecraft with a science laboratory on Mars, and by God, we're going to find out something new and something tremendously exciting.
safely on the surface, the Phoenix Mars mission would be the first NASA mission to be headed by a university, the University of Arizona. This meant that students would be directly involved with the mission, learning from an international collaboration of gifted scientists.
Currently, I am a member of the SSI camera team. The SSI is the Surface Stereo Imager. It's basically the main camera on the lander, and it's basically going to be doing most of the documentation on Mars. One of the girls I work with, we were talking about it the other day, and we're just like, you know, it's on Discovery Channel, it's on the Science Channel, it's on, you know, CNN, and we're just like, this is really big. Everyone that I know of can't believe I'm actually on this mission, but I don't know. It seems so small. I started out in such a small group that it was just like, okay, we're just building a camera, and now it's everywhere, and everyone's like so excited about this mission.
Scheduled to maximize every available moment on Mars, the Phoenix began taking photos, digging and sampling the soil, and testing the weather and atmosphere.
It was when we were looking at these images of the first trench that had been dug and wondering what this white material had been that I first started to look at what was happening in the shadows. And the shadows were very, very dark. And so on this particular day, after the first meeting, but before the second meeting, there was about an hour and a half to look at this. And as I was coaxing the contrast on these images, I could see that there was white material inside. And if we followed it across from one sol, from one Mars day to another Mars day, these white particles looked like they were getting smaller. And this has been one of the clues that what we are looking at, a very strong clue, that what we were looking at is ice.
After working for 151 Martian days on the surface, Phoenix sent its last radio communication. The Martian winter had set in, and there was not enough solar energy to provide power.
Well, for me personally, the Phoenix mission is the apex of my career. There's really nothing to match it to for me, because I had an opportunity to put together a set of science goals, bring together instruments and scientists that were the best in the world for answering the questions that were raised, and we did exactly what we planned to do. So it's really, to me, the most satisfying science endeavor I've been involved in.